Good.
Welcome to the little presentation that I have for you on rockets and delivery. The title of this presentation is Mighty Mo, and in short, momentum. This is all about momentum, and one of the laws of physics called conservation of momentum, in particular linear momentum. Now, what we have is we have one of the means of delivering a weapon, and in this case it's a rocket. It's a ballistic delivery involving a controlled missile, a guided missile. You can see from the picture that we have a launch, and there's a trajectory, and it goes to the target here. So right away you have some idea that the velocity of the rocket is very important to get to the right target. Now, the rocket is a special device, and it has mass. Its total rocket mass has 3 parts to it. The first part is the skin of the rocket. That holds the thing together. That would have the control, and inside the skin is the second part of the rocket. That's the fuel that we use to burn to get the rocket going. And of course, there's the third part of the rocket. That third part is the payload. It could be a satellite. In the context of this course, it's a nuclear bomb. Now, to study how the rocket works, we are going to apply the principles of momentum as set out by the physics law. Now, which physics law is that? That is the law that says to every action there's an equal and opposite reaction. We can imagine here, if we look at the rocket, we can see the little tail of burning fuel, and the gases and the burn are getting pushed out in this direction, this way. The opposite reaction is that the rocket moves that way. Now, clearly, as the rocket is moving, it's burning the fuel. Therefore, the mass is reduced. It turns out that when we look at this more mathematically in the next presentation, PowerPoint presentation, we will see that we will arrive at a mathematical description similar to that we obtained in our discussion of radioactive decay. In this case, if you want, the analogy is that what's decaying here is the amount of fuel inside the rocket. Now, what actually happens physically? Well, the rocket, say at time t1, has a momentum. That's the total mass of the rocket times its velocity measured at t1. The product of these two quantities is the momentum. Now, we look at another time, t2. It has a mass, m2, and a velocity v2. Now, what's happened between t1 and t2? Well, the skin of the rocket hasn't changed. We still have to hold everything together. The payload is there still. What's changed is the amount of fuel. So the rocket has become lighter because we burnt fuel in going from here to here. Now, if we burnt fuel, the mass, m2, of the rocket has decreased. That means to preserve the momentum, if this quantity goes down, the velocity here goes up. That means the rocket speeds up. And that's the way we get the speed of the rocket to go from the launch to our target. Later on, we'll describe this principle in more detail mathematically, but here it is. Momentum is conserved, so it's equal at these 2 times, but the mass is less, so the velocity goes up. And that's how we get our rocket to go from the launch to the target.